In today's video, I'm going to explain about the chemical properties of haloalkanes. Chemical reactions or properties of haloalkanes. Haloalkanes. Now, haloalkanes haloalkanes usually three types of reactions are taking place. First one is nucleophilic substitution reaction. And the second one is elimination reaction. And third one is reaction with metals. These are the three important reactions of haloalkanes. In the last video, I have explained about the reactions from which haloalkanes can be prepared. So in this video, I'm going to explain about these reactions of haloalkanes. So first of all, nucleophilic substitution reaction. This is also called SN reaction. So let me write SN reaction. Now SN reaction is of two types mainly. One is SN1 and another one is SN2. So in this video, let me explain about the mechanism of SN1 and SN2. In SN1, we need to check whether the carbocation is stable or not. This SN1 takes place in two steps. SN1 takes place in two steps and SN2 takes place in one step, single step reaction. Okay, and SN1 is dependent upon the stability of the carbocation. Right, formed in the first step after the halogen group is leaved, and this SN2 depends upon the steric hindrance. So this SN2 reaction occurs in those haloalkanes in which less steric hindrance is there. Okay, less steric hindrance means there must not be bulky alkyl groups. So these are the 2 points, and this is unimolecular reaction, unimolecular nucleophilic substitution reaction, unimolecular, and SN2 is bimolecular reaction. Okay, and one very important point of difference between SN1 and SN2 is in terms of stereochemistry. In SN1, racemic mixture is formed, and in SN2, inversion of configuration takes place. Right, inversion of configuration takes place. So let me explain by giving an example for this SN1 and SN2. Okay, let me rough this page to start the mechanism of SN1 reaction. In SN1 reaction, we need to take a tertiary haloalkane for showing the mechanism, because in tertiary haloalkane the carbocation formed will be a stable carbocation, right? And in SN2, I'm going to take one primary haloalkane. Okay, now first of all, let me write an example in which I can explain the mechanism of SN1. So this is our methyl group, and this is ethyl group, and this is propyl group C3H7, and to this tertiary carbon atom one halogen is attached, and if it is reacted with aqueous KOH, this Cl will be substituted by, this is C3H7 propyl, this is C2H5 ethyl. Okay, Cl will be substituted by OH minus ion, and K and the Cl will become KCl. So let me write the mechanism of this reaction. In the exam, they will not mention about SN1 or SN2. We need to decide whether the haloalkane is primary or tertiary, right? In primary, SN1 reaction usually does not take place, but there are some cases in which SN1 can take place in primary haloalkane also. But before that, let me explain about mechanism of SN1 mechanism. This reaction will take place through SN1 mechanism. So mechanism of SN1 for this particular reaction, right? going to load this step number 1, because SN1 reaction takes place in 2 steps, right? Step 1 the going to load this sigi haloalkanes, tertiary haloalkanes sidagi kedoba, this is C2H5 sidagi ne halogen se thokan gane ba, this bond will be broken and a carbocation will be formed. This is carbocation, this is C3H7, this is C2H5, right? This is a carbocation, and the Cl minus ion will be formed. Now this carbocation is stable because of the plus I effect of the 3 alkyl groups and hyperconjugation, right? This is a stable carbocation. So for SN1 reaction to take place, the carbocation formed must be a stable carbocation, right? Let me give one more example in which SN1 reaction can take place. This is an important question which had been asked in the council exam also. This is a benzyl chloride. This is a primary carbocation. This is a tertiary carbocation. Okay, in tertiary haloalkane, this is a tertiary haloalkane. In tertiary haloalkane, reaction will take place through SN1 mechanism, which is a tertiary carbocation formed stable carbocation, right? But in this benzyl chloride, which is a primary haloalkane, reaction takes place through SN1 also, right? Because this, in this case, benzyl carbocation will be formed. This is a primary carbocation, but this is stable due to resonance. Benzyl carbocation is very stable. This is equally stable with tertiary carbocation, right? So this is benzyl carbocation is also very stable. So in SN the reaction of benzyl chloride with a nucleophile will take place through SN1 mechanism in spite of being a primary halide, because the carbocation formed is stable. Okay, now let me complete the step number 2. In step number 2, the nucleophile will attack this carbocation. Let me show here. This is the carbocation, and the structure of carbocation is, like this, and its structure is, or geometry is, trigonal planar. I'm writing methyl here and C2H5 here. Now the nucleophile here, the nucleophile is OH minus ion. This will attack the carbocation from both sides. OH minus ion will attack from this side, right? And this OH minus ion will attack from this side also. So we will get 2 alkyl halide alcohols here, since this is a chiral carbon atom, right? So if OH is OH attacks the carbocation from left side, then OH will be attached to left side, right, like this. And let me write the 3 alkyl groups in this way. This is C3H7, and this is your CH3, and this is your C2H5, right? This is C2H5, and another product will be like this. To this C, OH will be attached to the right hand side, and this will be C3H7, and this will be our CH3, and this will be C2H5, right? This will be a mirror image actually. So let me write this product in this area. Let me erase it. Let me erase this because there is less space to write the product in that particular small area. So another product, another alcohol that will be formed will be this one. This will be OH, and this will be our C3H7, and this will be C2H5, and CH3. So these two alcohol will be formed. They will be mirror images of each other, and therefore one will be enantiomer of the another molecule, right? So these are the two products that can be formed in this particular reaction. If this carbon is not chiral, then we will get only one product, right? This is the mechanism of SN1. Okay, let me do another reaction which I can explain SN2 mechanism. So this is methyl chloride, and if it is reacted with aqueous KOH, then Cl will be substituted by what? OH, and KCl will be there. So this reaction will occur through SN2 mechanism, because this is a primary halide, methyl halide, right? And in the mechanism, of SN2, the nucleophile will attack a less steric carbon from backside, because this is our chlorine, and to this carbon 3 hydrogen atoms are attached. So if nucleophile is attacked from this side, from front side, this carbon will carry a partial positive charge, chlorine will carry a partial negative charge. So chlorine has excess of electron, and the nucleophile also has excess of electron, so front side attack is not permitted. So the only way the nucleophile OH minus ion will attack will be from the back side, right? So this Cl will be eliminated by, but before writing the product, transition state must be shown. This is the transition state. This will be OH, and this will be written like this. This position, 3 positions will be occupied by hydrogen. So this Cl will carry a partial negative, OH will carry a partial negative, and this carbon will carry a partial positive. So this will go out, and we will get this product. Cl goes out, and we will get this product. Now Cl was in the right side, but after substitution which comes in the left side. So this is called inversion of configurations. This is how SN2 mechanism takes place. This is actually transition state which is not stable. So SN2 reaction takes place in a single step, right? This is backside attack, right? This is backside attack by the nucleophile. Okay, now after this mechanism, I am giving some examples of SN reaction in haloalkanes, right? So for that, let me rough this page, some examples. some examples of SN reaction, SN reactions of haloalkane, right? So let me write this haloalkane, ethyl chloride, and if it is reacted with aqueous KOH, like I have explained in the mechanism, this Cl will be substituted by what? OH, and the KCl will be formed. And if it is reacted with alcoholic KCN, then the substitution will be by Cn, so we will get nitrile, right? And if this haloalkane is reacted with alcoholic AgCN, then substitution will take place by NC. This is isonitrile. This is IUPAC name of this compound is propane nitrile, and the IUPAC name of this compound is ethane isonitrile, right? This is propane nitrile, and this is ethane isonitrile. Similarly, if this haloalkane is reacted with alcoholic KNO2, then substitution by ONO takes place, right? This is nitritoethane, right? This is nitritoethane. Okay, now if it is reacted with alcoholic AgNO2, then substitution by NO2 will take place. This is nitroethane. Right? Okay, now another substitution reaction of haloalkane is when this ethyl chloride is reacted with, for example, sodium methoxide, then methoxide ion will be acting as nucleophile to attack this carbon atom and to displace this Cl. So we will get CH3 CH2O CH3. This is an ether, and the name of this reaction is Williamson synthesis. Okay, now another substitution reaction. Let me write one more substitution reaction of this ethyl chloride. When this ethyl chloride is reacted with, for example, CH triple bond CNA, this is sodium ethionite, and this ethionite group will be acting as nucleophile in our case, so we will get CH3 CH2, and to this carbon atom C triple bond CH will be attached, right? So we will get a higher alkyne by substitution also. Okay, one more last nucleophile can be Grignard reagent, so we can react this with methyl magnesium chloride. So this methyl group will be acting as nucleophile to attack this carbon to displace this Cl, so we will get propane as the product, right? These are some examples of nucleophilic substitution reactions of haloalkanes. I'm taking the same haloalkane so that we can write the products easily. Okay, these are some examples of SN reactions of haloalkanes. Let me take next reaction of haloalkanes. Next reaction is elimination reaction. Elimination reaction of haloalkane is also called dehydrohalogenation. This is also called dehydrohalogenation, right? This is a beta elimination reaction, and in this case, elimination of hydrogen from beta position, beta carbon, and elimination of halogen from alpha carbon takes place. right? This is the change that will be taking place in elimination of haloalkanes, and the reagents that can be used for this the hydrohalogenation are, first of all and most common one is alcoholic KOH, and the second one is we can use sodium sodamide NaNH2. We can use this also. This is a better the hydrohalogenating reagent actually. Okay, this is a stronger base than KOH. Or we can use RONA, that is what, sodium alkoxide in presence of an alcohol, and this R and the R, these two R's must be same, right? These are the reagents that can be used for the elimination of haloalkanes. Let me write one example. This is suppose CH3CH2Cl. This is our haloalkane, and if it is reacted with alcoholic KOH, then this is our alpha carbonatum, this is our beta carbonatum. From beta carbonatum one hydrogen will be eliminated, and from alpha carbonatum this halogen will be eliminated, and formation of alkene takes place. We will get ethene along with water, OH minus ion. This, let me show how this reaction takes place. From this alcoholic KOH, OH minus ion will be acting as a base. OH minus ion acting as a base, this will abstract this hydrogen from beta carbonatum, and this will form a pi bond, and this Cl will be eliminated like this. So OH minus ion and the H plus ion combine to form water, and this Cl minus ion and the K plus will form KCl as the byproducts. So our product in elimination reaction of haloalkane is alkene. So now let me give one more example in which we can form 2 alkene as the product. Suppose I'm showing the beta hydrogen here, and to this carbonatum if a bromine or chlorine is attached, and this is another beta carbonatum, right? This is our alpha carbonatum, this is our beta, also this is our beta. So these two beta carbonatoms are different. So if it is reacted with alcoholic KOH, then elimination takes place at these positions. This is beta, this is alpha, these two can be eliminated like this, and the double bond can be formed to this position between these two carbonatoms. And another possibility is, since this beta is different from this beta carbonatum, elimination of these two can also take place, and in that case a pi bond will be formed to this position between these two carbonatoms. So accordingly we will get two products, two alkenes. The first alkene is CH3, this hydrogen and Br, CH double bond, CH3, and the second alkene that can be formed in this reaction is CH3 CH2. This is eliminated, and double bond will be here. Now between these two products, two alkenes, which one will be our major product? The major product will be this alkene, which is more substituted alkene. So two alkyl groups are attached to these double bonded carbonatoms. This alkene is more substituted alkene. More substituted alkene will be our major product. This will be our major product, and this will be our minor product, right? So we need to write the major product, and if it is asked in the question to write the minor product also, you need to write this also. But if the question is about the major product only, then you need to write this only. Okay, so this will be major product, and this is according to Said-Jabs rule. This is Said-Jabs rule, right? And Said-Jabs rule is nothing but in the beta elimination of haloalkanes, the more substituted alkene is the major product. This is the statement of Sajab's rule, right? This is frequently asked in council examination, so please note down in this statement, Sajab's rule. Let me read one more time Sajab's rule, because I'm not going to write this statement here. According to Sajab's rule, in the beta elimination of, or in the dehydrohalogenation of alkyl halides, the more substituted alkene is the major product. This is according to hyperconjugation actually. Okay, this is about elimination reaction. Let me give you one more example of this elimination reaction, and the example is, suppose this is the haloalkane, and if it is reacted with alcoholic KOH, then what will be the major product? So for this we need to check how many different beta carbon atoms are there. So this is alpha carbon atom, next to alpha carbon atom there is beta carbon atom, this is beta and this is also beta, this and this are same. Okay, this is beta. So since we have two different beta carbon atoms, we will get two alkenes in this reaction, and the first alkene is this one. This will be our first alkene, and the second alkene that can be formed in this reaction is this one, right? Methyl will be there, and which one will be our major product, we need to check, right? To this double bonded carbon atom only two alkyl groups are attached, and to this double bonded carbon atom three alkyl groups are attached. We can say like this. Okay, so this can be treated as one alkyl group, this one is second alkyl group. In this case, this is an alkyl group, this is an alkyl group, and this is also one alkyl group. So our major product will be this one. This is according to Sajab rule. This is our minor product, right? Okay, these are some examples of elimination reactions of haloalkanes. Let me give about the third type of reactions of haloalkanes, that is reaction with metals, right? And here two metals are being mentioned in NCERT. So let me write the example here, right? The first example is, if this haloalkane, I'm taking ethyl chloride, and if it is reacted with magnesium, what will happen? And if it is reacted with sodium, what will happen? This is the two types of metals. These are the metals which are mentioned in NCERT. There are also other metals which can be reacted with alkyl halide, but that is not asked in the examination. So alkyl halide reacts with magnesium in presence of dry ether, in presence of ether, then we will get what? Grignard reagent, ethyl magnesium chloride. This is our Grignard reagent. And if this ethyl chloride is reacted with sodium in presence of dry ether, then alkane form torokaneba ko sigi alkyl group se sigi idoba double orakaneba habdi CH3 CH2 and CH2 CH3 sigi whose reaction sigi aina details da ko video ama same jakibani do yengbi organic ki playlist ko playlist sanga whose reaction ne su name reaction da phangani duga organic ki kano da su phangani ko. Okay, aduna sideda what will happen if these reactions are taking place at hydrated condition? Hydrated condition means this CH3 CH2 Cl is reacted with sodium in presence of water. What will happen? And if this ethyl chloride is reacted with magnesium in presence of water, what will happen? Right, these are the conditions that can be discussed in this type of reaction. So I'm writing the product only. Okay, let me write the products. When this alkyl halide is reacted with sodium in presence of water, then sodium and water reacts first before reacting with alkyl halide, because sodium reacts with water vigorously to form sodium hydroxide, and that sodium hydroxide will act as a nucleophile to attack this carbon atom to displace this Cl. So we will get CH3CH2OH as the major product along with hydrogen gas. Okay, and if this alkyl halide is reacted with magnesium in presence of water in hydrated condition, then methyl magnesium chloride will be formed, and that Grignard reagent will react with water to form alkane as the major product, right? This will be the product, and when it is reacted with sodium, then alcohol will be the product, right? Okay, let me complete this video here. In the next video I'm going to explain about the reactions to prepare haloalkanes and chemical properties of haloalkanes, right? This video is mainly about the for the students who are going to prepare the council exam. This is means what, revision type video. Okay, please share this video to your friends who are going to appear in the class 12 examination, final examination, and please subscribe to the channel if you are new to the channel. Thank you.